Good evening. We are back again. This is my fourth night in a row. I'm pretty proud of myself for being consistent. Not so much consistent with solving the puzzles, but consistent with trying to record and stream while I solve the puzzles. Um, all right, so today's day four. Um, we're just going to attack it the same way we did last time. So let's get our project set up. Apologies if this is a little um, repetitive because I keep telling myself that I'm going to remember to do the project setup during the day, and then I stay up too late, and then I wake up too late, and then work starts, and then work carries me away, and then I forget to do this part of it. So the first thing we're going to do is we're going to make a new directory. We are going to cd into that directory. We are going to what are we going to do? We are going to new up a input.txt file. We're going to new up a problem.md file. We are going to then create our .NET new console out. We're going to call this Ceres search. And that's where our solution will live. The solution to the, not the solution like the .NET solution, the solution to like the puzzle. And then we're going to create another one. Out Ceres search.tests. Because you always are supposed to write tests. I think that's funny because not everyone actually does write tests. So then we're going to do we are going to, first thing we're going to do is we're just going to remove that program program CS. We don't need that in that because we're using something called TUnit, which is a new testing framework that's based on Microsoft's testing platform, and you actually use a console app for setting up TUnit. It's all in their instructions and their docs of how to set it up, but that's why we're using a console application for both our solution and our test project. Okay, then we're going to say .NET add. We want to add to the test project, so we want to say .NET add Ceres tests, and we want to add a reference to Ceres search like that. Cool. And then we're going to go back up here to our top level. That's where my solution file lives at. We'll say .NET SLN add 04 Ceres search or Ceres search test. And then we also need to do search. That should tie everything together and it should build. .NET build. Huh. That's weird. It's like my inner key's not working. That's super weird. Did I break my keyboard? There we go. There is a circular dependency. Oh no, what have I done? Oh, I messed up the I messed up when I was adding the reference, didn't I? .NET add O3 no O4. Can I just think if I can I just drag it? Nope, can't drag it. Add reference to that guy. Alright, now can we .NET build? Oh. Oh, interesting. Okay, so I need to add T-unit. I bet I have to add T-unit. T-unit. It doesn't build this test project because it doesn't have a main method, but I'll bet if I add T-unit, it probably source generates. If I had to guess, I don't know, but I bet it source generates a main method. So what am I trying to do? .NET add 04 Ceres add package T-unit. Okay, I bet it builds now. Yeah. So that's interesting. Okay, so that's how T-unit. That's why T-unit makes use of the console application, because at the end of the day, with the new Microsoft testing platform, the test project actually gets built into an exe, an actual executable file. So I'm guessing that's all related, if I had to guess. What do we want to do now? Oh, let's get our input. I haven't actually read the puzzle yet, so let's get our input. It's a big input. Let's stick that in here. Cool. Wonderful. And then let's get our problem. Huh. I wonder why they're only that one. No index. I wonder if that means it's not searchable. Okay. If is the music too loud? No, I think it's fine. Okay, so let's go ahead and copy this problem. This kind of looks familiar to one that we did last year. Alt Z to turn on word wrap. You're probably wondering, like, why does he copy the problem into his repo? Honestly, it's because I did it last year, and I'm just trying to be consistent with my approach. And also because I don't know how long this advent of code is going to be a thing. And so I want to have a reference to the problem I did solve with the code I wrote, even many years down the road. So that's why I'm kind of preserving it for myself. It's probably definitely not exciting to watch me set all this up, but okay, I think we have what we want so far to get started. Let's go ahead and commit all this. Feature set up for. Well, actually, there's a couple other things I need to do. What's the other things I need to do? I need to copy some project stuff. So I always want to copy the input file. Just going to add this stuff in over here. And then I'm going to make the internals visible. I'm going to say no warn. Is it CA? I think it's CA 1822. This is just a warning that it shows when it thinks it can make a method static, but I don't want it to be static. And it just kind of ignores. It annoys me to have that suggestion. Yeah. Okay, I think we're all set up and ready to go. Let's make this sure this builds again. Yeah, wonderful. Okay. Feature set up for day 4. Yep, push it. Okay, let's read this problem and then let's get to solving. Blank slate. We're obviously doing something related to searching. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief set flash, you recognize the interior of the Ceres monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search, your puzzle input. She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with dots. So yeah, so it's like a crossword puzzle, right? I mean, that's basically, it's a word search, right? That's exactly what it is. So we're searching for Xmas. So there's an Xmas. There's an Xmas here. There's an Xmas here. There's an Xmas here. So what is that? How many is that? The actual, for example, okay, so that's a larger one with it all populated. In this word search, Xmas occurs a total of 18 times. Here's the same word search again, but where letters not involved in any Xmas have been replaced with a period. So this is our example problem, right? So this is our example problem. This is our example solution. Take a look at the little else word search. How many times does Xmas appear? That which is our puzzle input. Okay, so a couple things come to mind. So the first thing that comes to mind, which seems like it could backfire, but one thing I have in mind is we could theoretically. Oh no, we couldn't. I was gonna say we could theoretically remove all letters in here that aren't part of Xmas, but that won't work because we'd end up because yeah, we can't do that. We have to keep this grid. We can't replace all the letters that aren't Xmas because we can see from the example grid that they're using. That would I'd end up replacing all the letters in this thing, so that's a bad idea. You can't really turn it into a string and then look for a pattern of like a backward Xmas and a forward Xmas, because if you turn it into like just a string altogether, then you lose the diagonals. This seems like vaguely familiar to sort of operations that we had to do in a puzzle last year. But yeah, so just to kind of begin with, the first thing I usually do is I think about, okay, I need to parse this input into something I can work with. But I actually don't think I have to do really much parsing, because what I can do is I can basically just have a list of strings, and then because the strings themselves have an index or can be indexed like a list, like an array or a list, I essentially can just read the lines of the file in, and then I'll have the structure I need to be able to loop, right? So basically my grid will end up being a list of strings, and then each item in my list is a row, and then each character within each string is essentially a particular column within that row. So I should be able to just read this in, the lines in, and then I can work with just that list of strings. Because if you think about this, if you just had to find, like if you do a word search, you usually just stare at the word search till your eyes kind of find the word, right? But that's when you only have to find one occurrence. We have to find all of them. So if you kind of think of how you might do that, how would I search this grid kind of programmatically to make sure I find all of them? You basically would just start at the first position, and you know what word you're searching for, so you would then just look in all the directions you can. So you'd have something, you basically say, okay, is this the beginning of my word? Would you say, is this the beginning of my word? I don't know, would you say that? Yeah, I think if it's not the letter that your word begins with, you could probably bail early. Could you? I don't know. We can try that. But in any event, you basically are just going to programmatically go to each place in the grid, and then you're going to go in every direction, however long your word is, and every time you move, like for example here, I definitely can't go up because it's off the grid. I can't go left because that's off the grid. I can't go diagonal up, because that's off the grid. I can't go diagonal up and left. That's off the grid. I can't go diagonal. I can't go down and left because that's off the grid. But I can go right. And so what I could do is then I could say, okay, does M match the first letter in my... Does M match the first letter in my word? No? Okay. But let's say it does. Let's say I get to X, and I say, okay, X. Does X match the first letter in my word? Awesome. So now I can go write one character, and I can say, okay, does this letter match the first? And basically, yeah, so basically we're going to each spot in the grid, and then we're going to go out in every direction the length of my word, and at each place I'm just comparing the current letter I'm on in the grid to the current letter in my word, and checking if they match. And if all of them match, then I found it. Which I think that feels like non-optimal. Because I feel like there's cases where you could probably... But yeah, okay. Let's kind of go down that path. And let's just... So first thing I'm going to do is I'm going to set up my program CS like I did all the other program CSs. So basically going to take this kind of approach. And this is going to be using Ceres. But that's not, or not. That's not a namespace yet, so let me just take that out. Okay, so we're going to get the input file. We're going to make sure the file exists. We're going to see if they pass part 2. We're not going to read all the text. We're going to read all the lines. And then we really don't need a parser. Really don't need a parser. I think what I'm going to do is I'm just going to have a class called like grid. New grid. Yeah. That will be grid. And we can remove this. We don't need all that. And the input, the grid's going to take the input into its constructor. And then the grid is going to call some sort of method on it. So we can actually do this. Sometimes I just kind of like to, like, how would I like the ergonomics of this to work first? So yeah, so it's going to take in the grid, and then it's going to have some sort of method that's like search for. Because theoretically, this method's kind of agnostic of the word, right? We're just searching. Should it be searched for? Maybe it's something like count. Like count. How many times does X appear? Count appearances? No, count like occurrences. And then the word, which in this case is going to be Xmas. So this is going to be a string array. It's an input. And then I think I can just do a public method that returns an int. Because I can't imagine there'll be that many. My input's pretty big, but I can't imagine it. I can't imagine this needing to be a long. So public int count occurrences. And that's going to take a string, which is the word. And for now, we'll just throw new not implemented exception. Easy peasy. So then I think for my test, I just need one class at the moment. Just add a class for grid test, because that's where all my logic's going to live for the moment. Is in this grid class, because this method is basically going to do all the solving. And maybe we'll break this up into smaller methods. But for now, I think that's good. It's a little loud for me. Getting the sound right is tricky. Because I want it to be loud enough for people to hear, but I don't want it to be overwhelming to me. Yeah, okay, so let's write our first test, and let's use our input. So this is our test input. So our grid, do private read-only list of string, or I could actually string array. And this is going to be example input. Example input. And then we'll just paste these guys in here. And let's see, we'll use our duplicate cursors. I wish once you're able to duplicate your cursor like this, you kind of wish that feature was in every editor, like Google Docs, Microsoft Word. It almost like, it's one of those things that like once you have it, you're like, man, this would save me a lot of time in a lot of cases. Or like being able to select multiple things in a document at once and then change them all at once. That feature should be in every text editor. We'll put a comma. What's it complaining about? Is it just doesn't like the spelling? Yeah, it just isn't. And then we'll write a test. So if you're not familiar with TUnit, it's just a stand-in replacement, or should be a stand-in replacement for the most part, for XUnit or InUnit or MS Test. And so how you do it in an XUnit when you want to declare a test is you use something like fact, right? But for TUnit, the attribute uses test, and that decorates a method. And then almost all your methods are going to be async task if you are using TUnit's assertion library, because TUnit's assertion library is all asynchronous. If you're using something like fluent assertions, or then maybe they don't all have to be asynchronous. But for the most part with TUnit, they're all going to return tasks. So public async task, and we're going to say count occurrences when called with example input. It should return expected count. Expected count. Like that. And all we have to do is we say var result. We will new up a grid. And then we will count occurrences for Xmas. And then we can await assert, which assert is the static class that acts as the entry point for all the team's assertions. So in most cases, you're going to say assert that, and then to that method, you're going to pass your target of your assertion, in this case, my result, and then I'll say that is equal to, in this case, it should be equal to 18. Okay, let's go ahead and build. And then my tests should show up. Why are they not showing up? There we go. Okay, so this should fail. Yep, should just throw an exception, not implemented. Great. Okay, and so the first thing I need to do is just I need to start looping, right? So the first thing I need to do is I want to loop over every row, and then in that row I want to loop over every character for every column in that row, and essentially get the character that's at that place on the grid. That's kind of the first step, right? So we're gonna say for I'm not going to use I because I always feel like I. Well, I mean, I's fine sometimes, but in this case, the thing I'm looping on is a row. Or it's the row's index, I guess is technically what I'm. So I'm going to call this row index. And then so while that's less than word.length, we should increment row index. And what's that? What? Oh, we're doing a count. So we're going to say var total equals 0. And let's just go ahead and return that down here. Return total. Let me close this. Okay, so we're looping over the rows, and then once we're in here, we're going to loop again. I know, nested loops. What is this? O of n squared. O of n squared, polynomial time. That's what we're in right now. So O of int, I'm going to say O var column index equals 0. And then column index is less than. Oh, this is wrong. Not word.length. This is input.length. Word.length is what we're searching for. So for var column index equals 0. Column index is less than what? Less than well, it's going to be less than the length of this row that we're on. So let's say var row equals input row index. So it's while column index is less than row dot length, we will increment column index like that. And then let's just say var current character equals the input, and then that's going to be first get the row, and once you're in the row, get the column, and that's going to give us so the first time through this we should get in. So let's just debug that and verify. So we'll go to our tests, and we're going to debug this test. My test is going to fail because obviously I'm just returning 0. I haven't actually started incrementing the count. So what's current character? Current character. Oh, we need to step over this. Current character is M. We step over again. Current character should be M. Step over again. Where'd it go? Current character is M. Step over again. Am I on the right? Step over again. Hold on. Let's do stop. Let's say console dot right line current character. That way we can actually stop after the variable's initialized. No, I don't want to do for each. Okay, let me try to debug this again. It looked like it was just stuck. Always on M. 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 S. Yeah, there we go. M, M, S. And that should be X, and then X, and then M, A, S, M, and then we should go to the next row, and that should be M, and then S. Okay, yeah. So that's it. So we're just literally we're walking the grid space by space. Now, let's go ahead and just remove that breakpoint and continue. That's going to fail. Now, when we get here, this is where we need to start another loop. But what we do in this loop is we want to go in every direction the length of the word. So we're basically going to have I think 2 more loops. So yeah, so I'm at M here. And so now I basically want to go in each direction, right? So I want to go, I basically have, what is it? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I basically have 8 directions that I can go in, get when I'm at any one space, and I basically just want to want to take that direction, and I just want to keep going in that direction as long as the characters line up. So how can I loop over all the directions? It's like I need a list. I need a list of directions, like go up, or go for the up direction, loop over. For the up and to the right direction, loop over. So I think we can have private. So a direction, though, in order to move my place on the grid, I have to move the column and I have to move the row. Column, row, column, row, column, row, column, row. So my directions, it's basically we're navigating like a coordinate system. So I need like an X. I need how much should I move X and how much should I move Y in order to go up. So let's do private read only. And we basically want an int array of int like this, and it's going to be directions. And then in here, we'll basically say, so this would be move up. So this is just moving straight up. So this would be 0, because I'm going to make it XY. I kind of feel like I should make a type here, like a direction type. So I just make a record. It's like direction. And it's going to have an int, which is the X. What do we want to call this? X move, or let's call it X offset, Y offset. Oh. And then instead of this just being this, we'll say this is an array of directions. And so then it's going to be new and going to be 1 or no 0 1. So this is up, upward, up, and then to go left or go up and to the left, that's going to be new -1 1. So this is up to the left, which is essentially diagonal, right? These are our diagonal movements. And then we'll say new So we went up and to the left. Now we'll go up and to the right. So this would be 1, 1. You could probably, as you're looping, you could probably do all this like, go this way, go this way, go this way. But the nice thing about having a list of directions is I can just loop over the directions, and then I can call a function that does the walking to check for the word. That's what I'm picturing in my mind at the moment. So this is up to the right. And then, so we're going up, we're going left, we're going right, and then we're going to go left, which is going to be new 1, 0. This is left. Left. I could probably name these two. Like I could probably have like as much as I have a directions class, I could probably just have. This is fine for now. I could probably come up with better names for these, like to actually know each direction I'm going over. We'll say new. So we went left. Now we want to go right. So 1. Oh, whoops! I already made a mistake. So this is right. And this is actually left. Because negative left is, if I'm looking at the grid, going left is going -1. Okay, now we'll go the down direction. So straight down is going to be 0, -1. That's down. This is taking me longer to think about this part of it probably than... Okay, then we're going to go down to the left. So it's -1 and 1. Yeah, this is very similar, I feel like, to something we had to solve last year. Where I remember writing code that was like this. This is down to the left. Down to the left. And then new 1, 1. This would be down and to the right. Down to the right. So now these are all the directions we need to go in. Right? And so then now what I'm thinking is, so for each character, we have to walk all those directions. So we're going to have another loop that says for each var direction in directions, we need to call a function. So let's call it like I'm thinking it should be something like found word. So if found word, it'll now just return a Boolean. Then we will total, we'll increment the total and then return the total. So found word, it definitely needs the word, which is what was passed in up here, which we haven't used yet. And then I feel like seeing all of these loops makes me think that this is not the right way. But I don't know. Seeing all these loops makes me think it's not, that there's some other way, there's some more elegant way to do this. But remember, the key is to get it, to make it, to solve it, right? Like, it's kind of like that whole thing about like when you're building something, just get it, make it work. Um, right? And then what's it? It's like make it work, make it good, make it fast, kind of. So let's just make this work. So when we need the word, because that's the word is essentially going to give us both the how far we need to walk in any given direction, right? So if I'm at, let's say I'm at M, then the word is going to tell me how far I should search, so that I can verify that in every place in that direction the characters match, and then the word's also going to give me the characters that I need to match, and then I need the direction, and then I also think I need the indexes, and the reason why you need the indexes, or at least you need the current, the value of the index, because you need to know where you are in the grid. So, um, for example, I need to know that I'm at, if we call this 0, 0, I need to know I'm at 0, 0. Let me make this bigger. I need to know that I'm at 0, 0, and if I want to go to the right by 1, then I need to know that I'm at 0, 0, right? Just like if I'm at, let's call this 1, 0, then I need to know, in order to go one place to the right, I just need to take my directions and add them to the current index, the current indexes that I'm at. So this is also going to take row index and column index. And I think that's going to work. So let's make a private method. I mean, I could do another loop in here. Like, instead of just having that if statement, I could just loop right in the count occurrences method. But the main reason I'm separating it out is just for like readability sake, because at that point I'm going to be 4 loops deep. And what is that? That's 1, 2, 3, 4, 5. I would be almost to 6 or 7 levels of indentation. So I'm just gonna separate this out. So we need a string, it's a word. We need a direction, that's our direction. We need the row index, and we need the column index. And I need to make sure I give these types. And I need to give this a return type. And for now, we will just return false. And so what do I need to do here? So I basically need to loop again. So I need to loop over the word. That's the first thing. And then I need to just start advancing in that direction. So we'll say for, it's a simple for loop. And we'll call this, what do we want to call this? Letter index. And while that's less than word.length, we're going to walk it. Wait. Down here, I need the input, right? Because basically what I need to do is I need to say, okay, the word bar target let's call this, I don't know, these names are probably overly verbose, but I feel like having when I have things that are named really verbosely, I feel like gosh dang it. I feel like I can think about it better. So this is actually going to be target character index. This is the character. This is going to allow us to get the character that we want to. Hold on. Yeah, we need this index for two reasons. We need it, one, because this is going to allow us to get the target character that we're currently matching against. So this would be like target character equals word, and then target character index. So this is the character we're hoping to find at this particular place in the grid that we're starting at, that we're starting our search at. And then the other thing this index is going to do, the other reasons why we need the index and we can't just use a for each is, I mean, I guess we could use a for each, but we'd still have to grab the index and the character. Does that make it more elegant? I don't know. So let's not get distracted. Okay, so we got the target character, right? And now we need to figure out, okay, we have the target character, we have the direction that we're traveling, we have our current row or current column, so we know where we're starting. Now we need to say, okay, now we need to get our comparison character, the character we want to compare the target to basically say, does the current character we're on equal the target character? Awesome. Which actually makes a better. This is again, I'm making this way too verbose, but a better name for this is called current target character, because that's current, meaning it's because it's going to change, right? Each loop it's going to be different. So this is going to be current target character, like that. And then what we're going to say is we're going to say var current character equals what? So the current character needs to know about the input, which we can get. So the current character is going to be it can be row index and it can be column index. Oh, oops, sorry, index. It's going to be row index, column index. And but that will just give us the place we're starting our search at. What we have to do is we need with each loop, with each iteration, we actually need to move this. We need to move these indexes, right? So we're going to say we start at 0, 0, and let's say we're traveling right. I want to just move I want to move at least the column index. I want to move the column index by 1. On the first iteration, I don't want to move the column index. This should just stay the same. But on the second iteration of the loop, I need to move the column index over 1. And then on the third iteration, I need to move the column index over 2. So could this be just row plus that? Would that work? So just to think about this, the first time we loop through here, our current character would be in, right? Because it's going to be 0, 0, plus 0, because we start at 0. So it'll compare, it's going to compare this to this. Now, on the second iteration, this is going to be 1. Well, that's not going to work. So on the second index, yeah, this isn't going to work because this is going to, like in the case where we just want to move right, we only want to move right. This is actually, if I do this, it's actually going to move me both up a row and right a row. And also this is always going to be positive, right? So if I want to go right, that's fine. Or if I want to go down, that's fine. Hold on. These should be negative, shouldn't they? So my grid is down is increasing column number, up is decreasing column number. So this actually should be -1. Up, that's negative as well. Up, that should be negative. Up to the right, yeah. Up, -1, +1. Down should actually be a positive. Down, yeah, okay. Okay, never mind. Okay, okay, go back. So basically, the problem here with just using this index and adding it is it's always going to shift. It's always going to be shifting down. It's always going to be shifting right, and it's going to shift on every iteration. This is the whole reason I need direction. So we basically need to calculate the current character row index and the current character column index is what we need to calculate. So var current character row index, that is going to be equal to definitely the row index plus the plus it's going to be, so because it's the row, we want to move that row index whatever the direction is. Yeah, we want to move it by the direction offset. So if we do this way, So this is why we need both the offset and the current and this index, right? Because basically the current, so basically instead of the current target index being an incrementer, it's basically it's going to need to be a multiplier. So what I mean by that is on each iteration of the loop, we're saying wherever we currently are, we want to move by 1 is what all my offsets are going to do. They're going to say, hey, whatever your row index, move it by 1. But what the current target index is going to let us do is it's going to let us say, okay, I'm walking the length of however long the word should be. So if I'm on the first iteration, which is 0, that means that, so I'm basically going to multiply it, right? So think about this. So the first time we come through this loop, this is going to result in 0 plus 1. Let's just say in this case, the direction is we're going right. So it's going to be 0 plus 1 times 0, right? And so anything times 0 is going to be what? 0. So the first iteration is we stay in the same place. We're going to look here. The next iteration through is going to be, again, it's still going to be 0 plus 1. But now it's going to be times 1 because our current target character index went up. So now that row index gets shifted by 1, right? And so now instead of looking here, we're now looking here. And that's how we need to calculate both the row index, and that's how we need to calculate the current character column index equals column index plus direction dot y offset times 0. Yeah, this all feels very familiar to something that I've written before. Okay, which means now the target character is going to be this and this. But, so I've kind of developed this habit of, like, anytime I see square brackets, whenever I see myself indexing into something, I always think, is that valid? Right? So whatever this number is it a valid index? And I don't think it's gonna always, is it gonna be? Because this is always gonna start 0, 0. Yeah, so I basically just need to have a safety check here. I basically just need to safety check these indexes to make sure that I'm not trying to check something that's off the grid in a direction, right? Like I'm trying to go, I don't want to try to index -1. I don't want to try to index, -1 to -1 to the -1x or -1y. And I also don't want to try to go off the end of the grid the other way. So I think what I need to do is I need to say if current character row index is less than 0 if character index is less than 0, or character row index is greater than input dot length, we need to skip it, right? Oh, we just need to break. We just need to break out of the loop. Because basically when we start going off the every loop of this is just going to take us further off. So like let's say I started to go up. If I was at 0, 0 and I started to go let's say I start to go left, right? So I'm going off in the row index direction. No. Yeah, rows are my line. So if I let's say I start to go up, and so let's say I try to index -1. Well, now I've gone off the grid, and the next iteration is just going to be -2. So the first time I encounter that I'm off the board, I should just bail out of the loop because it makes no sense to keep searching in this direction. Um, and then I just need I need a check that's also, yeah, I can actually do this. So I can say, or if that's the row. So that's me checking the row. And then I can say if current character column index is less than 0, or current character column index is less than not the input length, but the input of the current row. So current or well, I guess the grid is the same. Each line is the same length, so I can actually say input 0 dot length. So basically, what this means, if if off grid, let's actually put that in a method. Private if is off grid. So this would be what would I pass in here? Row index column. Keep forgetting I keep forgetting my types. That's what I keep forgetting. Let's just put this in. I'm not a fan of the way Ryder likes to line those up. I just like to put mine like this. Are you gonna force me to do that? That's whatever. I've really never written this that way, so I'm not going to start now. And this is going to be row. This is row. Oh man, it really wants me to line these up. It's right. I'm not gonna get hung up on it. So if is off grid, current character row index, current character column index. We need to bail. There's no point in getting down here because if we do get down here, it's just gonna error. Okay, but if we do get to the current character, let's actually change this. So this should be true. And what we can say here is we can say if the current character equals the current target character, return false. If they don't equal. And so I guess what I'm accounting for here is because I'm not really accounting for directionality of the word with this because I'm basically going to search I'm just going to search each place in each direction. So there's probably an optimized version of this where I don't exhaust there's probably a smarter way to go about searching this that doesn't require me to search places where it's going to fail. I don't know what that would be though. I think this is going to be the best place to start. Okay, so why does it keep telling me this can be a for loop? I don't think this can be a for each loop because I think I need this index. Yeah, that's not going to work. You can't times this by 0. It's always going to be 0. Oh, it's probably telling me that because I'm not using this in any way. So this actually needs to be... I bet if I... That was an error. That was going to be an error. Yeah. So this is actually calculating like almost like a magnitude, right? It's like, oh, we know you want to go. We know you want to go to the right, which means moving we know you want to go to the right, but because we're walking the word, we want to know how far to the right you want to go. On the first loop, we don't want to go any number of spaces to the right. On the second loop, we want to go 1. On the third loop, we want to go 2. So we could probably give this a name that makes it more clear what we're calculating here. What we call that, magnitude of move or number of moves. Yeah, something like that. So I think I can try this now. Bar. What does this look like as a link expression? Oh, interesting. Okay. Oh, we don't need the current character because that's here. Go to that. This line's a little long, but okay. Let's run our test and see what happens. It's a lot of loops, man. It's a lot of loops. Expect the result to be equal to 18, but found 800. Yeah, well, that's not right. So let's step through this. So for everything I thought was clear thinking, does it never reach this? Okay, well that would explain. Oh, I don't think I want to break here, do I? I want to return. I want to return false. Now let's try. If I break here, I just exit loop and then return true. So let's try. Let's try that again. And now we found 0. Oh, I hope part 2 isn't tough because this is taking me longer than I thought it was going to. Why isn't this hitting? Debug. Okay. So current target character should be X. Should it be X? No, it shouldn't be X. Oh no, this should be because we're trying to max it against X. We're trying to find X. So then if we step over this, this should be 0 and 0. Is off grid should return false. What? If row index is less than 0, if column index, oh, right here, see? There's my bug. This is why writing tests is important. So this is basically saying my column index is always less than this. It's always less than that. So it's always less than that. Oh, God. What the heck? I've forgotten how to type the greater than sign. Oh no. How do I type? Why did all of a sudden I'm like having a brain fart? Could have sworn it was this guy. There we go. It's this guy. I was off a key. I'm using a little 65% keyboard, and it doesn't. It's got no keys, keycap labels. It's side printed. I think it looks good, but it's not the most practical. Now let's try this. Index was outside the bounds of the array. Interesting. Let's debug that. I thought I had checked all that. Is there a way to just... In VS Code, there's a way to say, like... It basically, whenever an exception is thrown, it pauses on it. Oh, where'd my... I want to look that up, because that's definitely something... That's definitely something I like about Visual Studio Code. Writer, pause on unhandled. Control Alt S. Doesn't seem to be working. Use the following options on the build, execution, and this. Okay, settings. Debugger. Break on user unhandled exceptions. Break on unhandled exceptions. So why is it not doing that? Do I have to define these here? Or maybe it's part of the unit testing, test runner. writer debug break on unhandled. Okay, I'm not gonna get bogged down. So this is, where's this happening? This is happening at line 69. So this shouldn't be happening because oh, this should be length -1, shouldn't it? Length -1. Off by 1 errors. It'll get you every time. Ah, let's go! Yes. Yeah, right. Because the length is not the same as the number of the index, right? So if you have an array the length of 8, the indexes are 0, 1, 2, 3, 4, 5, 6, and 7, not 8. Okay. Cool. This kind of bothers me, like having these comments. I feel like there's a way that I could like have this explicitly like, yeah, I don't know. I feel like there's a better way I could do this. And I also don't like how the comments aren't all lined up. Okay. Okay, so now what we'll do is we'll run this against our actual input. So we'll say .NET run -- project, and we'll say for .NET run for -- project 0 for not caps lock tab and then we'll pass it we want to pass it O4 input .txt. What? No, yes it does. The sum of the sum of instructions. No, it's not the sum. It's the number of occurrences. That was actually really fast. 7 milliseconds. I just figured with all those loops it would not be fast, but I guess it's probably because I'm indexing everything. Is that the same number? Yeah. Yeah. Oh my gosh. Why is this so difficult to copy this number? Please be right. Hey! That last year, that solution would have taken me a lot longer. Um, but that there was several puzzles last year that required that type of pattern where you're iterating over a grid. But you also had to do this like exhaustive search in all directions. I don't even know if maybe I solved it. I think I solved it. But yeah, that's definitely an improvement for me to recognize that pattern and be able to see that. I can definitely tell I've improved from last year, so that's a win. Yes, so let's go ahead and do a little bit of refactoring. Let's pull this into a separate class. Let's give this a namespace. What's the name of this puzzle? Ceres search. And now we can actually do using Ceres search. And this can actually live in the grid for now. And we're actually going to add a test here. And we're going to say private read only. Private, no, it can't be read only. It can just be private async task string array get puzzle input. This is going to return this is just going to return await file.read all lines path.combine the app context directory .txt, and then we're just going to write another test that does the exact same thing. When called with puzzle input, it should return expected count, which is going to be, what was it, 2644? And yay! Oh no, that's not all. That's not my test. Build. There we go. Oh, I need to get puzzle. Oh, get puzzle input. There we go. Nice. Heck yeah. I'm excited about that. Okay. Part 2. Let's open up our problem file. Alright, they're going to throw us a wrench in the... Oh, so now what? We have to look for hyphens or something? See, this is why you always want to... What the heck? This sounds hard. Okay, let's read part 2. The elves look quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It's an X dash mus puzzle in which you're supposed to find two MAS in the shape of an X. One way to achieve that is like this. Irrelevant characters have again been replaced with dots in the above diagram. Within the X, each must can be written forwards or backwards. Here's the same example from before, but this time all of the X muses have been kept instead. In this example, an X must appears 9 times. Flip the word search from the instructions. Flip the word search from the instructions back over to the word search side and try again. How many times does an X dash must appear? So I think this appears harder on the face than what it is. So this is an X. So that's 1, 2, 3, 4, 5, 6, 7, 8. Where's the 9th one? Oh, is that 9? So 1, 2. I guess in my mind, it really centers around the character A, right? You can't have an X without an A. So my thinking is we can basically use the same approach of what we're already doing, but the inner piece, where am I trying to go to? I'm trying to go to the grid. Okay, so what am I trying to say here? What I'm trying to say is that this inner piece, this basically do the same thing where we are going to walk each place in the grid, but now we only really care to stop and check if we find an A, right? Because basically we want to walk the grid. We can also start our check here, right? Because think of, you can't have an X, you can't find an X on the top, so there's no reason to search that row, and you can't find X on the bottom. There's no reason to search that row either. But for simplicity's sake, I say we just keep the same loop and I wonder if I can extract this to a private method that's something like private. Private. Just do void for the moment, but basically private void loop over, or private void walk grid. And then this should just return back func t callback. wonder if this will work. Block grid. No, I don't think that doesn't. Like it would actually work if I did like int row index int column index. Basically just trying to find a way to reuse this walking over. C# func delegate with multiple I don't have to specify. Oh, well, I meant, yeah, I guess I only have to specify the type. That makes more sense. Means this can go back to being row index. I know. I should rename them all at once, but don't return it. I guess I don't need a return type, do I? Oh, it's not a func, then it's an action. There we go. Okay, let's rerun the test, make sure that still passes. There we go. Okay. So then I think what we can do is we can say um, what are we supposed to get? Oh, count occurrences. We should now do public int count Xmasses? Count X. X. That doesn't look like a good method name, but far. Basically, you're going to do the same thing here, but we want to say found Xmas. Don't need a word. And our directions need to be different. Because basically we want to find A, and then we want to look diagonal, 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 diagonal. This is not the right way, but I think what I'm going to do is I'm going to do var directions to check equals a new list, and we want underscore direction So we want, let's just put all the diagonals here. C# slice array. Returns a specified number of contiguous elements from the start of sequence. Number of elements returned. So we want 1, 2, 3, 4, 5, 6. I'm going to take the first 6. Because we only want to check in those. We want to check up to the left, up to the right, down to the left, down to the right. Then private, ooh, bound. This is going to have a direction, int row index, int column index. No, I don't do that. I'm trying to think about what the pattern is that I'm looking for here. I basically always need M and S, right? So M or S. But if I find M here, this has to be S. And if I find S here, this needs to be M. And if I find S here, this needs to be M. Oh, so we really don't even care about up and down either. So okay, this bothered me, so I'm going to say private public const direction equals new 0 negative 1. Public read only direction up. The reason why I'm doing this is I just want an easier way to refer to these directions than having to remember this. The up 1, 0, -1. I don't want to do that. So this is direction dot down. This is public static read only direction dot up, down, left, right. Direction dot left. Direction dot right. Now I don't need these comments. Is a public static only direction. This would be down to I don't know why this is hurting my brain so much to think about this. Now, direction up to the left. Direction up to the right. Direction up, down to the left. And then direction up, down. Down. Now, what's kind of nice about the fact that so since these are records, they're going to be compared based on value equality. So what I can do is I don't have to do this anymore. I can still do this. And then when I'm looping here, What am I thinking here? I guess what I'm thinking here is um, var current character is going to be equal to input row index column index, like that. And then I want to say if current character is A, if it's not A, return false. Right? Because if it's M, I don't need to do any checks. I just need to do a check when I get to an A. When I get to an A, though, when I get to an A, though, when I get to an A, I think what I want to do is I want to loop. And I'm going to say for each direction in directions and I want to say if direction is direction dot oh no, if direction is equal to direction dot up or direction is equal to direction dot down or direction is equal to direction dot left or direction is equal to direction dot right, I want to continue. So if it's equal to any of those directions, I don't need to do any checking. If it is, if it's not one of those, then I need to calculate an offset. And I guess like I can do some. I think what I can do is I could do something just that's as brutal as this and say I don't think I need, actually, I don't even think I need to loop. I don't even think I need to pass the directions in. So then we say if so we say var top right equals top right index equals that's basically saying, hey, what's in the top right? I guess I do need to loop though, don't I? Because I'm gonna have to repeat this logic a whole bunch of times. Top right index equals okay. I think I do need to. row index to check. So this is the place we're gonna check, right? And then we can say, hey, is it if is off grid? Return false. Otherwise, our character oh, I'm waning here. I'm waning. So character to check here. At this point, what we're basically wanting to know is we're wanting to know I mean there's only a couple bar character to check. So what if we do bar equals Xmas map, which equals new dictionary of type direction and of type jar. And that's going to be, so this is basically going to be equal to Xmas map dot add direction and character. And then we could do like private pool is valid. So the dictionary, diction, basically need this. Need this, it's a map. And we're gonna say bar. Oh. So basically say if up to the right is not S or M, oh no, actually, we can do that up here. We can say if character check is not S or M, return false. Because these all have to be S or M. They can't not be. If check is not S or not oh, the character check is not equal S or not or what? Should this be a string? So what does it want me to do here? Okay. Yes. Okay. Then we add it to the map. Then we get down here and we say, okay, if up to the right equals down to the left. Turn false. Right, because we only have two letters to consider, S or N, and they can't be equal to each other. Same thing here. If up to the left equals down to the right, again, it's false. Oh. So we could probably actually move these up and just say up to the right does not equal down to the left, and up to the left does not equal down to, up to the left doesn't equal down to the right, and up to the right does not equal down to the left. That. We say if return is valid Xmas. This is probably Xmas. Oh, I don't need to pass this in. That's silly. It's a because it's a private field. I can just reference it directly in there. Okay. I think that's a valid solution. So let's give that a shot. There's a whole lot of coding without any any kind of small trial and error. So let's say test async task count x. This is call with example input expected count. Okay, so it's still the same example. So We want to count Xmas's. It says there should be 9 of them. I'm thinking this, excuse me, I'm thinking this is not going to work. But found 0. Wonderful. Okay, so this should be row 1, 0, 1, 2. So it should be 1, 2 when we first hit this. We should be on row 1, column 2. Column index 7. Row index 0. Oh, there's an A here. There's an A here. So then it should hit this. No, it should hit this at some point. Yep. Yep, okay. Now the next time we go back here is 1, 2. And this one should count. So we should end up with we should end up down here. What? 1, 9. That's here. So stop. Debug. Yep. Okay, now let's step over this. Step over. Step over. What's the current direction? Current direction is -1, 1. So that's up to the left. S. -1, 1 is S? Oh, that's this. Okay. Oh, that's wrong. Okay. So it's not if character does not equal S or character, it's if it doesn't equal both of those, then it doesn't. An item with the same key has already been added. Well, that shouldn't be possible. Down to the left, down to the right, up to the left, up to the right. 1, 2, 3. I don't understand why I'm ending up with duplicate directions. -1, 1, and... Oh, because I have duplicates. Down to the left. Up to the left. Up to the left. Yes, up to the left. Down to... That should be 1. 1. No, down to the left. That should be negative, negative. There we go. Now run unit test. Let's go! Okay. Now let's run them all. Just make sure they all still work. Let's go, 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 let's go. Okay, so what did I do here? Right? So Um, can you do this with a one-liner? Can you do like found Xmas? Okay, so the the basic idea here was I'm going to walk the grid. So I factored that logic of looping into a private method that just takes an action, which is a method. It'll accept a method. It'll pass the current row index and the current column index on the pass. It'll pass that into that callback, and then in that callback, I can define a function that uses those. So a little bit of functional programming, just so I can reuse that that loop logic, but then change what I do, basically change the evaluation I run on the current character essentially. So I refactored that, and so now what I'm doing is I'm walking over the grid, and instead of checking for finding a word, I'm checking if I'm finding an Xmas. And so when I check to find the Xmas, what I do is I get the current character, and I check to see is that current character an A? Because if the current character is not an A, I don't care because I can't have an X without an A. So once I do get to an A, then what I do is I basically create a map. So what I do is I loop over all the possible directions, and if any of the directions are directions I don't care about, meaning it's not in the diagonal, then I continue to the next direction. Once I get to a direction I care about, I calculate the row index and the column index that I need to check. So I get the coordinates for up to the left, up to the right, down to the left, down to the right, and then I check and make sure that those coordinates, that row index and that column index are actually on the grid. If those aren't on the grid, then I return false because I can't make an X by moving off the grid. Finally, then I get the character to check, right? So you can imagine at this point, I've reached the letter A, and I've checked, and now I'm checking this for this letter, which is a letter of M, and I'm saying, okay, M, this letter is an M, right? Because the only way I can form the Xmas is with an M or an S, right? Or an S or an M. So this character, every character I'm looking at has to be an S or an M. So if it isn't, then I bail out, I return false. If that character is an X or is an S or an M, then I add it to my map that I'm building. And my map is basically just a dictionary that's a map between the direction and the character that's there. So at the end, I'm going to have a dictionary that says, okay, up to the right is the letter M. Up to the left is the letter M, up to the right is the letter S, down to the left is the letter M, and then down to the right is the letter S. Once I have that map, I pass it into this function, which I called isValidXmas, which then just makes sure that we have the right pairs, right? Because we can't have an S and an S, right? We need an M and an S. So at that point, all we do is we just check, hey, are these two characters in these two directions, are they equal to each other or are they not equal to each other? Because that's basically the only thing we need to worry about. Because we've already made sure they're the right they're one of two correct characters. Now we just need to make sure they're not the same. As long as they're not the same, then we know there's an S here and there's an M there, or there's an M there and there's an S there, which makes it valid. Okay, now let's run this on the actual inputs. And I do feel like this is overly complicated, the solution I came up with. There's probably a way to walk this, check here, then check here, right? And you're sort of validating M. Good. But the problem with doing it that way, in my opinion, is then you have to validate the combination, right? So it's like, oh, up is M. Or do I? Because I could say up to the left is M, then down to the right needs to be S. And if up to the right is S, I mean, it's basically the same logic I'm doing. It's just I've done it this way. This is probably not necessary, but I just didn't want to have a separate variable for directions. In any event, let's run it and see if it actually solved it. Because if it didn't solve it, then it doesn't really matter. Oh, I need to go to my program.cs. And so now what I'll do is I'll say if it is part 2, we'll do something different. We can actually say up here, we can say var grid equals new grid takes the input. And then we can say grid dot count xmasses. I kind of thought I'd be done under 2 hours, but then part 2, it took me a lot longer to write the solution to part 1 than I thought it would. Part 2 was kind of tricky for me. So that still works. That's part 2. Hey, that's pretty good, man. This is fast. 8 milliseconds, 7 milliseconds. Yes. Oh man, that feels good. Like that is a challenge that last year I would have struggled with, um, or I feel like I would have struggled with. And today I felt like, okay, I recognized the pattern, I recognized the grid, I knew I had to walk it. Um, yeah, I'm very happy with that. Uh, I think my favorite thing I did in this solution is this. Right? I love this method. I love that C sharp lets you do kind of this blended world of like object oriented code, but also functional code when you need to. You can have higher order functions like this where, you have this need to do the same thing. You just want to change what you do when you get to a particular place. I really like that. Yeah. I'm not, this solution, this part 2 solution probably could be a little cleaner, but it does the job. Um, yeah. Anywho, let's add a test for our puzzle input, and we're gonna call it a day. Count xmasses. It should return expected count, and we're gonna do count xmasses. And this should return 1952. Oh. How do I get to test? Alt Shift 8. That doesn't seem like a good shortcut. Let's go. Let's go. That feels good. I just, yeah. That one was fun. Took me right on the nose about 3 hours, but that was yeah, that was a fun one to do. Um it was fun because it was challenging, but I felt like it was one of those things where clearly my ability to solve these has improved from last year. It's a clear, just kind of knowing myself and remembering how I did last year's. So yeah, I hope you guys enjoyed this. I hope you're getting something out of it if you're watching these. Um, if it helps you with your solution, maybe you just want to sit and code along with somebody else. I hope you're I don't know. I hope you're enjoying. So my plan is to come back tomorrow and try day 5 and hopefully get that one done relatively reasonably. Probably not gonna sit and go at it for 6 hours like I did on day 2, but I think 2 to 3 hours is a reasonable attempt to stream and record. Yeah, so hope you guys have had a good day, had a good week. I will see you in the next one.